and I say, find the derivative at 27 for this function. Now, honest to goodness, if you saw this on the test, this is the way I wrote this problem on the test, what do? You take the derivative of x to the 1/3 and plug it in, right? You would not do what we're about to do. I'll give you a simple problem. It will get more interesting. Okay? All right. So here's what I'm going to do. I'm going to say I have two worlds. Last year we called them Bizarro land and real land. What do you want to call them this year? Inverse land and real land? We need two distinctive places so you guys don't go, I don't know. You got to meet them first? Okay, so, all right. So we're going to call this undecided land. Undecided land. I misspelled that. That's really good. Okay, and then I got real land. This has got to be real land. Undecided. Undecided. Call it Rachel land? All right, fair enough. Okay, so we might call it Rachel land. We may end up calling it that for future reference. So I got real land, I got this. So in real land, I wanted to find the derivative. This is my function, right?
Yeah.
And I wanted to find my derivative at 27. Okay. So in this weird world we live in, f of x would be equal to the inverse. What's the inverse of x to the 1/3? X to the 3rd. Okay? Now again, usually this is going to be given to you, so it's not a real big deal that you'd be able to find the inverse, but you switch the x and y's and you solve. That's how you do it, right? So what's the derivative in undecided land? We're gonna make Madeline do this one because she's naming this and she needs to meet the place. That's what she said, I think. So what's the derivative in undecided land of this function? 3x squared. So f prime of x equals 3x squared with me so far. Now I got a problem because I want to know where I'm going to take the derivative. I can't use 27 because that's in real land. That's a separate place. I need to know in this mirror reflection land, this weird land of inverses. I need to know what 27 corresponds to. To do that, I'm going to have to figure out the point. So how am I going to figure that out? Plug it in for what? For the y. Right? Because I want to know what the x is. So I'm trying to find the point 0, whatever this is, comma 27. So I'm going to plug it in for y. 27 equals x cubed. I see some blinking. That's going to give me x is equal to what? 3. So the point over here is 327 is the same as what point in real land? 27, 3. So that's the corresponding point, right? So in this undecided land, where am I going to take the derivative? At 3. F prime of 3 is equal to 3 to the 2nd power. And that would be what? Oh, that's a terrible example. Well, whatever, we'll deal with it. What's the derivative? 27? So if the derivative is 27 in undecided land, what's the derivative in real land? 1 over 27. There's my answer. Okay. So the deal is you take you go to the inverse, you find the derivative. Once you found the derivative, you're going to do what with it? You're going to also find the point that corresponds. Usually by solving for y, because that's not going to work. Or if you have the point here, you can flip it and put it over here. Okay? But keep them separate, 2 different places. Now, Madeline, you've now met both places. I need a name for this, so we have a name for it. Inverse land. Okay, it's inverse land. What land? Okay. Everybody look at it. It says, why do this at all? Here we go. Try the first problem there. You should be able to at least stumble into this problem a little ways. Why do this at all? Unless you have to know the derivative for an arc sine, you're going to be stuck having to use the inverse. How do you find an inverse, sir? Van Willis, how do we do it? Switch the x and y's, solve for y. That's how you get the inverse function, right?